So we've looked at the product property for exponents, or product property of exponents. And when we have the same base and we're multiplying the terms, we add the exponents. Now we're looking at the quotient property for exponents. And what that is, in formulaic form, it means that if I have a to the m over a to the n, that equals a to the, we can subtract the exponent in the denominator from the exponent in the numerator. So a to the m minus n. So with our first problem, part A, we have x to the 15th over x to the 10th. We have the same base in x and a numerator and a denominator. So we're dividing x to the 10th under x to the 15th. So x to the 15th divided by x to the 10th. That's why we call it the quotient property. So that means we can subtract the exponents. So this is x to the 15th minus 10, which equals x to the 5th. In part B, we have the same base in 6. So again, we can subtract the exponents. So this is going to equal 6 to the 14 minus 5, which is 6 to the 9th. Technically, we could simplify that one further if we wanted to write out the big long number that 6 to the 9th equals, but this will suffice for now. The exponent can end up being negative. In part C, we have a similar problem as to part A, but the exponent in the denominator is greater than the exponent in the numerator, so we're going to end up with a negative exponent. So that equals x to the 18 minus 22, which equals x to the negative 4th. And now what do we do with negative exponents? If you remember, we move the term to a denominator and then change the sign of the exponent, because this is the same thing as x to the negative 4th over 1. So that equals 1 over x to the 4th. We don't want any negative exponents in a simplified expression. Same thing with number, or part D. That equals 12 to the 15 minus 30, which equals 12 to the negative 15th, which equals 1 over 12 to the 15th. Move it to the denominator and change the sign of the exponent. So again, this is looking at the quotient property for exponents. And again, in formulaic form, it looks like this up here, and it simply means that if we're dividing two numbers that have the same base, we can subtract the exponent in the denominator from the exponent in the numerator.